In this module, we'll talk about usage limits and quotas that apply to a Maps API for Business account. In particular, we'll take a look at how to calculate usage for the various APIs for a Maps API for Business customer. Next, we will identify the quotas and limits that exist for the APIs and compare these numbers for Maps API for Business with those that exist for the free version of the API. And finally, we'll discuss the errors that get generated when exceeding these quotas and how to go about handling them. Each of the APIs measure usage slightly differently, and to make sense of these calculations, it's important to understand the following terms that are used in these calculations. We use the term page view to measure usage of the JavaScript API as well as the image APIs. When you purchase your Maps API for Business account, you buy, with the license, a certain number of page views, let's say 1,000,000. And as you load the JavaScript API in your application or make requests using the static maps or Street View image API, you start consuming page views. To be precise, every single load of the JavaScript API consumes one page view, and every single request to the image API consumes, again, one page view. For web services, however, we use a whole different formula. We have queries per day and queries per second. Queries per second is defined as the maximum number of requests per second that you're allowed to make to any of the web services. We use this short-term limit as a throttling mechanism to prevent scraping of data or abuse of our systems. We also have a long-term, or what we call the query per day limit, which is defined as the maximum number of requests you can send over a 24-hour period. And lastly, a map load is defined as loading a Google map on a page. It is important to note that we do not charge our customers based on the number of maps created or loaded. Only non-business applications get limited by the number of map loads. However, people sometimes use the terms map loads and page view interchangeably, which is not correct. The reason perhaps is because we use the JavaScript API in order to embed a Google map into the application. And a common problem we see a lot with poorly implemented solutions is page views being incurred without a corresponding map load. That means you load the JavaScript API into your page. However, you do not create any map after you load the JavaScript API. In other words, you are consuming a page view, which is clearly a waste of a page view because there is no map or overlays being displayed on top of the map. And so we'll take a look at how to handle this. Let's understand the page view consumption for JavaScript API in a little more detail. Now, like I mentioned, a single load of the JavaScript API consumes exactly one page view. So that means every time you reload the page, you're bootstrapping the API, and so that will consume additional page views. However, once the API is loaded and you create a map, any interaction between the user and the map, for example, panning the map to the left or to the right, zooming in and out, or clicking off a marker, does not generate more page views. Simply because none of these actions causes the JavaScript API to be reloaded. Sometimes though, page views may be generated without map loads, as highlighted in the previous slide. This sometimes happens during development phase where, let's say, developers may create a template which calls the JavaScript API and use this template for all the HTML documents irrespective of whether a map will be displayed or not. Ideally, you want to make sure that you do not have a page view without a corresponding map load to avoid quota usage. In the support portal, which we'll take a look at later, you can track page view usage and also check for map loads under the analytics section, and so any mismatch should be investigated. A solution that we recommend is, instead of loading the API in the script tag in the head of your HTML document, you can load the API asynchronously. What that means is you will link it to, let's say, the click of a link, which could say something like click here to see a map, and the API will only be loaded based on this kind of user interaction. This will ensure that it is only when the user decides to view some sort of map, only then will the API be loaded. That way you can make sure that every page view that gets consumed will result in one or more map loads. For static maps and Street View Image API, every single request consumes one page view. Now, common designs for store locator applications, for example, typically have these calls and hence the images within info windows. This may cause high page view consumption by individual users with just a few random clicks, and so you want to be careful how these APIs are being called. For web services like geocoding, directions, distance matrix, and so on and so forth, we use two measures. We have the short-term queries per second and the longer-term query per day to measure the usage of web service APIs. The query per day limit is spelled out in the slide, and so for each API, we have a limit of 100,000 requests per day or per 24 hours. Now, one thing to note is that it doesn't follow any specific timing for any time zone, but rather depends on when the first request was sent. That's how we start counting the 24-hour period. So let's say you send the first geocoding request at 3 p.m. in your time zone. That's the beginning of your 24-hour period. And so from 3 p.m. then to 3 p.m. the next day, you have a quota of 100,000 requests for geocoding. And the same story can be applied to all the other web service APIs. You can find this information in the FAQ section of the documentation site. Within this table, another thing to take note of is that for each of these APIs, besides the QPD limit, there could also be an additional limit. For example, for directions, we have a limit of 23 waypoints per request. So if you have a lot more waypoints in a request, you will need to split that request, resulting in more requests being sent. Apart from the QPD limit, we also have the query per second limit, and for Maps API for business customers, this defaults to a value of 10. So you want to make sure you don't send more than 10 requests in a time span of 1 second. For non-business customers, the QPS limit equals to 5 requests per second. Now, some watch points when working with these limits. First, if you need higher usage limits, whether it's for QPS or QPD, you're able to buy additional limits, and you can contact your account manager to purchase these additional limits. Also, take note that you're not required to buy additional limits for all the web service APIs. For example, if you use a lot more geocoding compared to direction and distance requests, you can buy additional QPS or QPD quotas for geocoding only. Another thing you want to take note of is that these higher limits and any additional uplift that you purchase for one or more of the web service APIs will only be available provided you use the client ID in your request. If you do not use the client ID, we will not be able to distinguish between your request and that of any other customer or even that of a free API user. So it is really important that you use the client ID, as all the higher quotas and uplifts that you purchase will be mapped against your client ID. One final thing on these limits is that these limits are applied to the client ID, and so you want to stay away from designing applications that work with these limits, assuming that they are applied based on the IP address rather than the client ID. For example, if you had 100,000 addresses to geocode, by breaking them up into chunks of 10,000 addresses and sending them from 10 different IP addresses will cause you to hit the QPS limit really soon, because we apply the QPS limit on the client ID and not per IP address. And so you want to make sure that when you design applications that make calls to these web service APIs, you take into account the collective number of requests that are being sent per 24-hour period and also within a period of 1 second to make sure you don't hit the QPS and QPD limits. Sometimes, instead of using the HTTP interfaces for the web services, you may want to use the classes within the JavaScript API to access the backend web service. For example, instead of using the geocoding web service API, you could use the google.maps.geocoder class available within the JavaScript API to do forward or reverse geocoding. In such a scenario, since you're using the JavaScript API, the limits for QPS and QPD do not apply in this situation, and so since you had to load the JavaScript API, you will consume one page view for the API to be loaded. In such a scenario, you don't have to worry about QPS or QPD limits simply because you're not using the web service APIs to do your geocoding requests. Since you're using the JavaScript API geocoder class, you will be consuming one page view when you load the JavaScript API. However, it is important to take note that there is a large daily allocation granted on a per user session basis. So what that means is once you create the geocoder object within your JavaScript API application, you can send a lot of geocoding requests, which is not limited by some global limit, nor by the IP address. This is to ensure that irrespective of whether we're using a mobile browser or a desktop browser, users will be able to take good advantage of this object. And so since there is a large daily allocation of the number of requests that you can send per user session, as your user base grows, the limit grows with your user base. And so almost in a lot more cases, it may make sense to use client-side geocoding compared to using the web service API version of the geocoding service. This discussion is done in more detail in an article called Geocoding Strategies written by Mano Marks of the Developer Relations team. It talks about when does it make more sense to use client-side geocoding over web service API and vice versa. And although it's using geocoding as the example, the same concept applies to all the other web services that are available as part of the Maps API family. And hence, it's definitely worth a read for developers who want a better understanding and be able to design applications to make more efficient use of the quotas. Since web services have the QPS and QPD limits, we may encounter errors when our applications exceed these limits. And it's important to understand what these errors are so we can better prepare to handle them should they arise. There are three possible error status codes that are listed on this slide. The first one is the status code 620. Now this will only appear if you were using the version 2 of the geocoding API, which is deprecated. Version 3 of the geocoding API and all the other web service APIs like directions, distance, elevation will generate the over query limit error status code when you exceed the QPS or QPD limits. The final error category or status code is the 403 forbidden, and this will get generated after you repeatedly generate the over query limit. We'll get into more details of that in the next slide. So one of the main reasons why we return these errors is so that we can prevent abuse of the web services and also to identify any design that intend to repurpose the use of the API, which may be in violation of the terms of service. Now, when you start sending requests for a particular web service API, for example, geocoding, let's say, and you start sending more than 10 requests within 1 second, you'll be hitting the QPS limit very, very soon. And so what's going to happen is you'll be either receiving the 620 or the over query limit error status code in the response. Now, if this continues to happen repeatedly, you'll be blocked for a lot longer time with the 403 forbidden status code. A similar error will be generated when you exceed the QPD limit within the 24-hour period, and further requests will be blocked until the quota is refreshed. So you start the next 24-hour period, or if you decide to purchase additional quota for that particular web service in question. Now let's take a look at some typical scenarios that may cause some of these errors to be generated. The first one, when you run long batch jobs and fail to estimate the number of requests that you may end up making for a particular web service within a 24-hour period, you may very easily exceed the QPD allocation for the day and hence end up generating the over query limit. which after a while will block any further requests for a longer period of time. And so the easiest solution to this situation would be to break up long batch jobs and make sure that you stay very well within the QPD limits that is applicable for that particular web service that you're making a request for. Another situation that we see very common is the buildup of requests in the request queue due to situations like network congestion, for example. What happens in these situations is that due to the buildup in the queue, you will very easily hit the 10 query per second limit or whatever uplift that you may have purchased for that particular web service. And so again, you'll be generating overquery limit, and if this is not detected soon, repeated occurrences of the overquery limit will end up in a 403 forbidden status code, which means that your request will be blocked for a longer period of time. And so the easiest workaround for this problem is to introduce some sort of backoff or throttle within your script. Let's say you introduce a 2 to 3 seconds backoff that could ensure that no more than 10 requests are being sent in a period of 1 second. This way you will ensure that you don't hit the QPS limit, and any occurrence of overquery limit error code will very likely be generated because of the QPD violation and not the QPS. The final scenario is again a common problem that we see a lot when developers design applications assuming that the limits are applied per IP address instead of per client ID, which is obviously wrong. You want to make sure that when you send requests that are separated over IP addresses, you take into account the collective number of requests that are being sent within a period of 1 second and make sure that they do not collectively exceed the 10 QPS or whatever uplift you may have purchased. And also the number of requests that are being sent over a 24-hour period of time does not exceed the QPD limit that you have for your account.